system.
That's how they raise the animals up to the arena.
Have you ever wondered why modern skyscrapers require major repairs after only 50 years, while Roman ruins have stood for millennia? We are accustomed to considering ourselves at the pinnacle of technological progress, with our computers and high-precision instruments. But the truth is that if we had to build the Colosseum today, we would most likely fail. The engineers of that era possessed knowledge that we lost over the centuries and are only now beginning to rediscover. This structure is not just a stadium, but a complex machine hidden beneath a stone shell. The giant amphitheater was built without motorized cranes, computer modeling, or modern materials. Its walls witnessed the rise and fall of an empire, survived earthquakes, fires, and barbarian raids. Every stone here is steeped in the history of incredible engineering solutions that border on magic. We look at it as an architectural monument, but in fact it is a monument to human audacity and impossible calculations. Watch this video to the end, and you will learn why even with our technology, we would not be able to recreate this masterpiece as it was conceived by its creators. What if I told you that everything you believed about the primitiveness of ancient builders is not true? We are used to thinking that concrete is a modern invention that only became the foundation of our cities in the 20th century. However, the Romans used this material on an industrial scale long before us, and their recipe was more perfect than ours. The secret lies not only in the components, but also in the very approach to creating artificial stone. Roman concrete, or opus cementitium, has a unique self-repairing property that is not available to modern mixtures. Scientists have only recently been able to unravel the chemical composition of this incredible material that binds the walls of the Colosseum. The basis was a mixture of lime and volcanic ash extracted in the area now known as the Phlegraean Fields. This ash, known as pozzolan, reacted with lime and water to create incredibly strong crystalline bonds. Modern concrete degrades and cracks over time, allowing moisture to penetrate the structure. Roman concrete, on the other hand, becomes stronger when it comes into contact with water, triggering a chemical reaction that heals microcracks. It is thanks to this unique property that the Colosseum has stood for almost 2,000 years. Despite the complete lack of maintenance, the huge vaults and arches that support the enormous weight of the stands are cast from this very material. The Romans did not simply mix the ingredients. They carefully selected the aggregate for the concrete depending on the tier. Heavy and dense tuff was used for the foundation to ensure maximum stability. As the structure rose, the materials became lighter to reduce the load on the lower floors. For the upper tiers, a mixture of light pumice and brick rubble was used to reduce the weight of the structure. This was an ingenious engineering solution that prevented the building from collapsing under its own weight. Imagine the complexity of the logistics required to deliver different types of fillers to the construction site. The builders had to clearly understand exactly what composition to pour into each specific formwork. A mistake in the choice of material could lead to the catastrophic collapse of the entire section of the amphitheater. The technology of laying concrete was also radically different from the modern pouring of liquid mixtures. Roman concrete was much thicker, almost dry, and had to be carefully tamped down by hand. Workers laid layers of rubble and mortar, compacting them with special tools to a monolithic state. This process required enormous physical effort and time, but ensured that there were no voids. Every cubic meter of the Colosseum's walls contains thousands of hours of hard manual labor. The brick or stone facing of the walls served not only as decoration, but also as permanent formwork for the concrete core. First, the outer brick walls were erected, and then the space between them was filled with concrete. This sped up construction, as there was no need to wait for the concrete to dry completely before building the next level. This technique required perfect synchronization between the masons and concrete workers. The whole process resembled a huge conveyor belt that never stopped for a minute. Interestingly, the Romans did not reinforce concrete with iron, as we do today. They relied on arched structures that worked under compression rather than tension. Metal inside concrete rusts and expands over time, tearing the stone from the inside. Paradoxically, the absence of reinforcement made Roman buildings more durable over the millennia. Their engineers intuitively understood the principles of durability better than we do with our calculations. Remarkably, the exact formula and mixing proportions were lost with the fall of the Roman Empire. Medieval builders tried to replicate this success, but their mortars crumbled to dust after centuries. Only now, using electron microscopes, are we beginning to understand the true genius of Roman chemists. They created a material that lives in symbiosis with the environment rather than fighting it. This forces us to rethink the very concept of technological progress in construction. It turns out that the walls of the Colosseum are not just stones, but the frozen result of lost high technology. We can build higher, but we cannot build more reliably using modern standards. This fact is a bitter reminder that knowledge can be lost forever. I'm very interested to hear your point of view. What do you think about the fact that we cannot surpass the ancients in the durability of our buildings? Write about it in the comments. Are you ready to learn the truth about how materials were actually delivered for this construction project? The construction of the Colosseum was not only an architectural challenge, but also a real logistical nightmare at the time. More than 100,000 cubic meters of travertine, a durable limestone, were needed to build the amphitheater. This stone was quarried in Tibur, modern-day Tivoli, located 30 kilometers from Rome. Imagine an endless line of carts traveling daily between the quarry and the construction site. A special road designed for super heavy loads was built to transport such enormous volumes. Ordinary Roman roads would not have been able to withstand the constant movement of carts loaded with multi-ton blocks. Engineers reinforced the pavement, creating a dedicated road exclusively for the needs of this grandiose construction project. It was the first industrial highway of this scale in history. Traffic on it was strictly regulated and did not stop day or night. Each travertine block had to be not only cut in the quarry, but also delivered without damage. The stones were marked at the quarry so that the builders would know exactly where to place them. It was a complex accounting system where a mistaken marking could halt the work of an entire sector. Construction managers coordinated the flow of materials with the precision of modern dispatchers. A delay of one cart could cause a chain reaction of downtime throughout the entire chain. In addition to travertine, huge amounts of tuff, bricks, and volcanic ash were required. Tuff was mined closer to the city, but its volume was also estimated in thousands of tons. Rome's brick factories worked at full capacity to ensure a continuous supply. The entire city was transformed into a service mechanism for a single construction site. The region's economy received a tremendous boost from this government contract. The delivery of iron for fastening the stone blocks deserves special attention. The stones did not simply lie on top of each other under their own weight. They were connected with iron clamps. The construction required about 300 tons of iron, which had to be forged and delivered. These brackets were filled with lead to prevent corrosion and ensure a tight fit. In the Middle Ages, barbarians hollowed out these brackets from the walls, leaving the characteristic holes that we see today. Wood for scaffolding and formwork was also brought in huge quantities. Forests were cut down for hundreds of kilometers around, changing the landscape of Italy. Long, straight trunks were needed to create complex lifting mechanisms and cranes. The logistics of supplying wood were no less complicated than delivering stone. Each stage of construction required its own type of wood, from sturdy oak to flexible spruce. Human and animal muscle power was used to operate these lifting cranes. Huge wheel steps were created, inside which workers walked, setting the mechanism in motion. This system allowed multi-ton blocks to be lifted to a height of 50 meters with remarkable precision. The operators of such cranes were the elite among the workers, possessing unique skills. Coordinating the lift required the coordinated actions of dozens of people on the ground and at height. We must not forget about supplying the army of builders itself, which numbered thousands of people. This huge mass of people had to be fed, watered, and provided with tools every day. A whole city of warehouses, workshops, and canteens grew up around the construction site. Water was delivered through specially designated aqueducts to meet the needs of production. Organizing the workers' daily lives was an important part of the success of the entire project. Managing such a flow of resources required a complex bureaucratic machine. Preserved documents indicate strict accountability for every sesterce spent and every block delivered. Corruption and theft were severely punished, as the construction was the emperor's personal project. Vespasian and his sons personally supervised the work, understanding the political importance of the project. This logistical operation proved that Rome was capable of mobilizing resources on an unprecedented scale. They turned the chaos of delivery into an orderly system that ran like clockwork. No modern project can boast such efficiency without the use of digital technologies. But the most surprising thing was hidden not within the walls, but beneath them. What do you think was here before the first stone was laid? I discovered this by accident while studying old topographic maps of Rome, and this fact struck me. The place where the Colosseum now stands was originally completely unsuitable for capital construction. Here in the lowlands between the Esquiline, Palatine, and Caelian hills was Emperor Nero's huge artificial lake. It was the center of his golden house, a luxurious palace that was detested by ordinary Romans. Emperor Vespasian made a bold decision to drain the lake and return the land to the people by constructing a public building on it. The task of draining the lake seemed impossible with the technology of the time. The engineers had to not only pump out the water, but also divert the groundwater that constantly flowed into this lowland from the hills. They designed and built a complex system of drainage channels surrounding the future foundation. These channels worked by gravity, using the natural slope of the terrain towards the Tiber River. The accuracy of the slope calculations was phenomenal. An error of even 1 degree would have rendered the system useless. The bottom of the former lake consisted of silt and marshy soil, which was unsuitable for heavy construction. The builders had to dig a giant pit and replace the soft soil with a reliable foundation. They created an elliptical concrete ring foundation more than 12 meters deep. It was a colossal slab designed to distribute the weight of the entire structure and prevent it from sinking. The world had never seen anything like it in terms of the scale of underground work. The foundation was poured in layers, carefully compacting each layer of concrete. This work was carried out in conditions of constant struggle with seeping water. The drainage system had to work flawlessly even before the walls were erected. The engineers created a kind of dry dock in the middle of the marshy lowlands. If the drainage had stopped working for even a day, the excavation would have turned back into a lake. Interestingly, the shape of the foundation, an ellipse, created additional difficulties in marking out the site. The Romans did not have laser levels. They used the simplest tools, a plumb line and a plumb bob. Nevertheless, the error in the geometry of the giant ellipse is only a few centimeters. They used a complex system of geometry based on 4 centers of curvature. This mathematical precision on the ground is the basis of the entire harmony of the building. A network of collectors was laid under the foundation, which still functions today. Even today, during heavy rains in Rome, this ancient system continues to drain water. Archaeologists who descend into the underground often find these channels dry and clean. This testifies to the incredible quality of the engineering design of the hydraulic systems. The Romans conquered nature not by force, but by cunning and knowledge of hydraulics. The decision to build on the site of the lake also had a deep political meaning. Vespasian literally erased the memory of the tyrant Nero by filling his favorite lake with concrete. Where the emperor once enjoyed solitude, tens of thousands of citizens could now entertain themselves for free. It was a powerful PR move by the new Flavian dynasty. Architecture here served as a tool of state propaganda. The builders also provided for the possibility of refilling the arena with water. In the early years of the Colosseum's existence, naval battles were held here. The drainage system had sluices that allowed the outflow to be blocked and the bowl to be filled with water from aqueducts. This dual purpose of the drainage system makes the project even more unique. The building was a transformer long before the concept existed. The complexity of underground work is often underestimated because it is hidden from view. But it is the foundation and drainage that are the main contributors to the Colosseum's stability. Without this invisible work, the walls would have collapsed into the swamp within a few years. This reminds us that the most important thing in any endeavor is a solid foundation. Today, it is difficult to imagine the amount of earthwork that was done by hand, with shovels and baskets. Thousands of slaves carried the soil on their shoulders, meter by meter, clearing the way for history. If you enjoy learning about these hidden details of history, Don't forget to like this video, and be sure to subscribe to the channel so you don't miss new videos about ancient Rome. Are you ready to learn the truth about how the Romans controlled the weather inside the Colosseum? One of the most mysterious and complex parts of the amphitheater was the Valarium, a giant retractable awning. The sun in Rome can be merciless, and spectators would not have been able to sit through hours-long performances under the scorching rays. Engineers designed a structure that surpasses many modern stadium roofs in complexity. It was not just a piece of fabric, but a complex system of ropes, blocks, and sails. The Valarium was attached to 240 wooden masts installed around the perimeter of the upper cornice. The stone consoles that supported these masts have survived to this day, and you can see them on the outer walls. The fabric itself consisted of separate strips called sails that could be unfolded and folded independently. This allowed shade to be created in specific sectors, following the movement of the sun across the sky. An open hole remained in the center, the oculus, providing ventilation and lighting for the arena. Special skills were required to operate this giant web. Ordinary workers or slaves could not handle rigging of such scale and complexity. Therefore, a special detachment of sailors from the imperial fleet in Miseno was recruited to maintain the Valarium. About 1,000 professional sailors were permanently stationed in Rome, working exclusively at the Colosseum. They moved along ropes at dizzying heights, as if on the masts of a ship. The entire structure weighed hundreds of tons, and the load on the walls was enormous. Engineers had to calculate the tension of the ropes so that they would not collapse the upper tier into the arena. The wind created additional sail force, turning the awning into a giant wing trying to fly away. A system of blocks and winches compensated for gusts of wind and kept the structure stable. It was a true triumph of aerodynamics and mechanics. The fabric was most likely made of linen or thick canvas, possibly dyed in bright colors. Some sources claim that the fabric was decorated with stars or scenes from myths, creating the illusion of the sky. When the awning was unfurled, a special microclimate was created inside the bowl. Air circulated due to temperature differences, creating a light breeze for the audience. Sound was amplified under the dome, making the roar of the crowd deafening. The unfolding mechanism worked synchronously at the command of the senior officer. Sailors had to pull hundreds of ropes simultaneously to ensure that the awning unfolded evenly and without distortion. Any inconsistency could lead to the expensive fabric tearing or the rigging becoming tangled. It was a spectacle in itself, watched by thousands of spectators before the games began. Technical aesthetics were intertwined with functionality. Today, even with the help of computers, we cannot fully reconstruct the exact rigging scheme. There are several versions of how the ropes were intertwined, but none of them is considered definitive. This shows how complex and unique the engineering thinking of the Romans was. They solved problems intuitively and practically, creating systems that we cannot figure out theoretically. Interestingly, the smell of a huge number of people and animals under the tent would have been unbearable. To solve this problem, the Romans used sprayers of scented water with saffron. A fine mist of water settled on the spectators, cooling them and masking unpleasant odors. It was an air conditioning system of the 1st century AD. The comfort of the spectators was thought out to the smallest detail. The Valarium was the most visible symbol of the emperor's care for his people. It provided shade and coolness to everyone, regardless of their social status. This technological marvel made attending the games not just a spectacle, but a comfortable leisure activity. But how was it possible to quickly let 50,000 people in and out without crowding and chaos? The Flavian amphitheater could accommodate, according to various estimates, between 50 and 80,000 spectators. The main task of the architects was not only to accommodate this mass of people, but also to ensure their quick and safe movement. To this end, an ingenious system of entrances and exits was developed, which the Romans called vomitoria. Despite the unpleasant associations with the modern word, this term comes from the Latin vomere, to vomit. The building literally inhales people before the performance and vomits them out afterwards. There were 80 numbered arched entrances on the first floor around the entire perimeter of the building. 76 of them were intended for ordinary citizens, and the 4 main entrances were for the elite. The numbers above the arches, engraved in Roman numerals, have survived to this day and are visible above some of the passageways. Each spectator had a token, a tessera, indicating the number of the entrance, tier, and seat. This navigation system is almost identical to the one we use in modern stadiums. Inside the building, the flow of people was separated by a complex system of corridors and staircases. The architecture was designed so that different social classes did not intersect with each other. Senators walked through their own corridors, horsemen through theirs, and the plebs climbed to the upper tiers. This prevented conflicts and crowding, as well as maintaining the social hierarchy. The corridors were wide and well lit to ensure maximum throughput. Calculations show that the entire Colosseum could have been filled in just 15 minutes. The evacuation in case of an emergency took even less time, about 5 minutes. Even many modern sports arenas with their electronic turnstiles cannot achieve such speed. The angle of the stairs and the width of the aisles were calculated taking into account the biomechanics of crowd movement. Roman architects had a perfect understanding of crowd psychology and the physics of human flow. The vomitoria led directly to the stands, evenly distributing spectators across the sectors. This prevented bottlenecks from forming in the aisles between rows. People went straight to the right area without wandering around the huge amphitheater in search of a seat. The system was so intuitive that even an illiterate peasant could easily find his sector. Simplicity and efficiency were the main design criteria. The seats themselves were also strictly regulated in terms of width. Wide marble chairs were provided for senators, where they could bring their own cushions. For ordinary citizens, the seats on the stone benches were narrow, about 40 centimeters per person. On the top wooden tier, intended for women and the poor, people had to stand. The architecture of the building was a physical embodiment of the social structure of Roman society. Safety was ensured by a high parapet separating the arena from the front rows of spectators. In addition, there was a system of rotating cylinders on the wall of the podium that prevented animals from jumping onto the stands. Spectators could feel completely safe, even though they were only a few meters away from the predators. Ensuring the safety of the public was a priority for the organizers of the games. The vomitorium system proved its effectiveness over centuries of operation. Even today, stadium architects study the plans of the Colosseum when designing new arenas. The principles of crowd flow distribution, laid down 2,000 years ago, remain the benchmark. We have only added escalators and elevators, but the basic logic has remained unchanged. The Colosseum was not just a theater, but a perfectly tuned machine for serving people. Every arch, every step had its own functional purpose. There were no unnecessary details here, only pure utility elevated to the rank of art. This machine worked flawlessly as long as the empire was able to maintain it. What if I showed you a time machine hidden right under the feet of tourists? What we see now in the center of the Colosseum is not an arena, but its exposed insides, which were called the Hypogeum. In ancient times, these labyrinths were hidden under wooden flooring, sprinkled with sand, creating the illusion of solid ground. The Hypogeum was the true technological heart of the amphitheater, a hidden factory for producing special effects. Here, on 2 levels of underground passages, hundreds of people worked feverishly to ensure the show on the surface went on. This space was densely packed with mechanisms, cages, and corridors. There were dozens of elevators capable of lifting scenery and performers into the arena. The system was designed so that objects appeared on the surface suddenly, as if by magic. To the audience, it looked as if the earth had opened up and given birth to a forest, a mountain, or a herd of animals. The element of surprise was the main goal of this complex mechanism. The lifts were powered by a system of counterweights and winches rotated by slaves. Archaeologists have discovered grooves and holes from bronze mechanisms in the walls of the Hypogeum, allowing them to reconstruct how they worked. There were at least 24 movable platforms capable of lifting loads weighing up to several tons. These were the prototypes of modern stage plungers used in the world's best theaters. Coordinating the elevators required perfect coordination and teamwork. The narrow corridors of the underground were dark, stuffy, and incredibly noisy. This is where the scenery, weapons, and props for various game scenarios were stored. The mechanics who worked here were true engineers, capable of repairing complex mechanisms under stressful conditions and in the dark. Any elevator malfunction during a performance could cost the person responsible their life. The reliability of the mechanisms was constantly checked. The system of hatches in the wooden floor of the arena was camouflaged so as to be invisible. The hatch covers open at the right moment, releasing the contents of the elevator and immediately slam shut. The floor had to be strong enough to withstand the running of elephants, while also having dozens of openings. It was a complex engineering task to combine the strength of a monolith with the functionality of a sieve. The sand covering the floor not only absorbed liquids but also hid the hatch gaps. The Hypogeum also had a connection to the outside world through an underground tunnel leading to the Ludus Magnus, a gladiator school. Fighters could enter the arena without passing through the crowd of spectators on the street. This added mystery and allowed the intrigue to be maintained until the very moment they stepped onto the sand. There was also a separate passageway for carrying out bodies and wounded people, hidden from public view, called the Libitina Gate. Ventilation in the underground chambers was a serious problem, which was solved with the help of a sophisticated system of shafts. Nevertheless, working conditions below were hellish due to the heat and smells. But for the spectators above, everything happened easily and effortlessly. This duality, glamour above and hard labor below, was the essence of the Roman world. Technology served spectacle, hiding its unsightly underside. The complexity of the Hypogeum grew over time. It was rebuilt and improved several times. Domitian, Titus's brother, added the brick walls we see today, replacing the original wooden structures. This made the underground more reliable and durable. The stone corridors allowed for the installation of even heavier and more complex lifting mechanisms. Today, the Hypogeum is open to the sky, and we can appreciate the scale of this hidden engineering. It resembles a dismantled clock where all the gears are visible, but the hands no longer move. Without understanding how the Hypogeum worked, it is impossible to comprehend the true grandeur of the Colosseum. It was not just a stadium, but a high-tech theater. How difficult do you think it was to coordinate the actions of people below and above without radio communication? In the early years after its opening, the Colosseum could do what seems impossible even today: turn into a lake. Ancient sources such as Martial and Cassius Dio describe the holding of Naumachii, naval battles involving real ships. For a long time, historians considered this to be fiction or exaggeration, as they could not understand how it was technically feasible. However, modern research has confirmed that the arena could indeed be flooded. The same system used for drainage was used for this purpose, but in reverse mode. Water came from the Claudian aqueduct, which ran near the amphitheater. Engineers created a system of sluices and valves that allowed the arena bowl to be quickly filled with water. Calculations show that it took about 7 hours to create a pool 1.5 meters deep. This is an incredible speed for filling such a volume without electric pumps. A huge problem was the waterproofing of the concrete foundation bowl. To prevent water from seeping into the ground and washing away the walls, the concrete was coated with a special waterproof compound. The use of pozzolan concrete, which we mentioned earlier, played a key role here. It held water perfectly, turning the basements of the Colosseum into a giant pool. This was a test of strength for the entire foundation. The ships used in the battles were not full-size galleys, but smaller replicas. They had a shallow draft and no heavy keel so as not to touch the bottom. Nevertheless, they were real floating vessels on which the crews fought. Maneuvering in the confined space of the arena was incredibly difficult. Spectators saw a real naval battle in the center of the city. After the performance, the water had to be drained quickly to prepare the arena for the next day. The water was discharged into the same system of collectors leading to the Tiber. The powerful flow of water washed away all the dirt and debris, acting as a self-cleaning system. Emptying the pool took even less time than filling it. The engineers made full use of the force of gravity. However, the Naumachii in the Colosseum did not last long, only a few years. After the construction of a complex 2-level Hypogeum with stone walls under Emperor Domitian, flooding became impossible. The elevator mechanisms and animal cages could not function in water. The amphitheater was finally repurposed for land-based games, sacrificing the sea-based ones. Apparently, the complexity of maintaining the water arena outweighed its spectacular nature. Traces of this system can still be found in the lower tiers of the foundation. Strange channels and traces of waterproof plaster confirm the bold theory of flooding. This demonstrates the versatility of Roman engineering, ready to change the purpose of a building at the will of the emperor. They were not afraid to experiment with scale and the elements. Performances on water required incredible coordination and preparation. A leak could wash away the foundation and cause the walls to collapse with thousands of spectators inside. The risk was enormous, but the Romans took it for the sake of grandeur. Their confidence in their calculations bordered on recklessness. The Naumachii in the Colosseum remain one of the most striking examples of technical audacity in antiquity. Turning a stone stadium into a lake and then back again was a task worthy of the gods. It was the ultimate manifestation of man's power over nature and matter. Where did the empire find the funds for such a grandiose project after the Civil War and Nero's squandering of the treasury? The answer lies in events that took place thousands of kilometers from Rome, in the province of Judea. The construction of the Colosseum was essentially financed by military spoils obtained after the suppression of the Jewish revolt. In 70 AD, Titus, son of Vespasian, captured Jerusalem and plundered the Second Temple. The temple's untold treasures, accumulated over centuries, flowed into Rome. Gold, silver, sacred relics, all of this was put on display during the triumphal procession. But the main treasure was alive. Tens of thousands of prisoners turned into slaves. It was the sale of these people and their labor that became the economic foundation of the construction. The Colosseum literally stands on a foundation of war and conquest. It was a way to convert military success into political capital within the capital. An inscription was found on one of the marble slabs of the Colosseum, which has been restored. It reads, "Emperor Caesar Vespasian Augustus ordered this new amphitheater to be built with funds from the spoils of war." This is direct evidence that the building was a trophy. The Romans did not hide the source of funding, but were proud of it. For them, it was a symbol of the power of Roman arms. The Flavians used this money not to build private palaces like Nero, but for the public good. It was a brilliant populist move that strengthened the new dynasty on the throne. They gave the people back their land and gave them spectacles bought with the money of their defeated enemies. The Colosseum became a symbol of the emperor's generosity and the greatness of Rome. The empire's economy received a powerful boost from the influx of captured gold. Huge sums were also spent on paying skilled workers and engineers. Slaves did the heavy lifting, but the masonry, engineering, and decoration were done by free-hired specialists. The construction project created thousands of jobs, reducing social tension in overpopulated Rome. Money circulated within the city, reviving trade and crafts. It was a kind of national project to overcome the crisis. The scale of funding can be compared to modern Olympic construction projects, only multiplied many times over. No loans or borrowing, only pure gold and silver from trophies. The Roman economy at that time operated on a winner-takes-all basis, and these resources were materialized in stone and concrete. Interestingly, part of the funds went to rebuilding the city after fires and civil war. The Colosseum was just the jewel in the crown of Rome's massive renovation program, but it was the one that required the largest and most stable investment over a period of 10 years. Stopping the funding would have meant political ruin for the Flavians. The history of the Colosseum's financing is a lesson in the real politics of the ancient world. The grandeur of art here is inextricably linked to the cruelty of war. The beauty of the arches was paid for with the gold of the temple and the freedom of captives. This is a duality that cannot be ignored when looking at the ruins. The flow of gold from Jerusalem dried up, but the stone bought with it remained. It was perhaps the most enduring investment in history. The money invested in PR and architecture continues to pay dividends to Rome in the form of tourists. Why do we see only the skeleton of former greatness today, destroyed and gnawed away by time? The Colosseum was ruined not so much by Rome's enemies as by the Romans themselves and the forces of nature. After the fall of the empire and the ban on gladiatorial combat, the building lost its functional purpose. Without constant maintenance, the complex drainage system became clogged and the floors began to rot. But the first terrible blow was dealt by nature. Powerful earthquakes in 847 and 1349 collapsed the southern side of the outer ring. The piles of collapsed travertine became a gift for the inhabitants of medieval Rome. Why extract and transport stone from distant quarries when there is a mountain of ready-made blocks in the center of the city? The Colosseum turned into a giant free quarry. Its stones were used to build palaces, churches, bridges, and fortifications. A famous saying goes, What the barbarians didn't do, the Barberini did, alluding to the noble families who plundered the monument. The iron clamps that held the blocks together were torn out with particular zeal, as metal was expensive. The barbaric removal of the clamps weakened the remaining walls, making them vulnerable to new tremors. The building was literally dismantled piece by piece, layer by layer. The marble cladding was burned in furnaces to produce lime. Beautiful statues and decorations were turned into simple mortar. In the Middle Ages, an entire residential quarter grew up inside the arena, with houses, workshops, and even a small church. People lived in the arches, planted gardens where the stands had been, and grazed cattle in the arena. The majestic amphitheater became a fortress for feudal clans who fought each other. The walls that had seen emperors now served as a shelter for bandits and livestock. History humiliated the giant, turning it into a dormitory. It was not until the 18th century that Pope Benedict XV stopped the destruction by declaring the Colosseum a holy place where the blood of Christian martyrs had been shed. Although the historicity of mass executions of Christians here is debatable, this decision saved the ruins. The first attempts to preserve and strengthen what remained began. The brick buttresses that we see today at the edges of the collapsed walls were built in the 19th century to support the structure. Vegetation was also an enemy of the building. The roots of trees and shrubs growing on the ruins were destroying the masonry. At one point, botanists counted more than 400 species of plants in the Colosseum, creating their own microclimate there. Cleaning the walls of vegetation in the 19th century was perceived by romantics as vandalism, but engineers understood that the roots were tearing the stone apart. What we see today is only a third of the original volume of the building. The rest was dismantled and became part of the body of Rome itself. St. Peter's Cathedral in the Palazzo Venezia contained fragments of the Colosseum. It did not disappear. It simply dissolved into the city, giving rise to its new appearance. The destruction of the Colosseum is a vivid example of how the values of civilization change. The pragmatism of descendants prevailed over respect for ancestors. The greatest engineering creation became simply a resource for survival. But even in its dilapidated state, it continues to capture the imagination. The story of its decline is no less magnificent than the story of its construction. It shows the incredible strength of its creators. Even when it was broken, burned and looted, it refused to fall completely. It stands as a reproach to our wastefulness and the transience of our own creations. It may seem absurd, but with our lasers and cranes, we would hardly be able to build an exact replica of the Colosseum. The first problem is materials. The travertine quarries are depleted or closed, and the secret of that very pozzolan concrete, although chemically deciphered, is difficult to reproduce on an industrial scale. We cannot wait decades for the concrete to set, as the Romans did. Our economy demands speed, while Roman technology demanded time. The second reason is modern building codes and safety regulations. The Colosseum, with its steep stairs, lack of railings in many places, and narrow passageways, would never pass modern inspection. Fire inspectors would have shut it down at the excavation stage. The Romans built with a different attitude to risk and responsibility. They placed the grandeur of the design above individual safety. The cost of such a project today would be astronomical. We are not talking about billions, but tens of billions of dollars. Hand-cut stone, unique masonry, complex mechanical systems, all of this costs a fortune today. The manual labor of craftsmen, which was cheap at the time, or free in the case of slaves, is now the most expensive item on the bill. Economically, such a project would be completely unprofitable. But the main obstacle is the loss of the philosophy of building for the ages. We build buildings with a design life of 50, 100 years, after which it is easier to demolish them and build new ones. The Romans built for eternity, eterna. We have no motivation to invest so many resources and reserves of strength in a structure that is supposed to outlive civilization. Our thinking has become too short-term. In addition, we have lost the skills to work with massive stone without reinforcement. Modern architects are accustomed to steel and glass, to lightweight structures. Designing a building that is held up only by its own weight and arched struts is a forgotten art. We have forgotten how to feel stone the way they did. Technology has given us opportunities, but it has taken away our intuition. Of course, we could cast a concrete copy and cover it with stone-like tiles as they do in Las Vegas, but that would be just an empty decoration, devoid of the soul and structural integrity of the original. The real Colosseum is an honest structure, where every stone bears a load. A fake will never have the energy of the original. An attempt to recreate the Colosseum would also face legal and ethical problems. It is impossible to use labor in such harsh conditions today. Environmental standards would not allow the felling of forests and the excavation of quarries on such a scale. We have become more humane and cautious, and this is the price we pay for not being able to repeat the wonders of antiquity. The paradox is that, with greater knowledge, we have less determination. The Colosseum is a product of totalitarian will and unlimited power aimed at creating a masterpiece. In a democratic society, agreeing on such a project would take longer than building it. So the Colosseum will remain unique. We can restore it, study it, scan it with lasers, but we cannot rebuild it. It belongs to its time and its people, and perhaps that is for the best. Let it remain a reminder of what humanity is capable of at the height of its power. The Colosseum is not just ruins in the center of Rome. It is a mirror of a great and terrible civilization. Its walls hold secrets of ingenious engineering that we are only beginning to understand, and memories of cruelty that we are trying to forget. The builders of this marvel combine the chemistry of concrete, the logistics of an empire, and precise mathematical calculations to create a building that has stood the test of time. We have learned how they manage water, light, and crowds to create a spectacle that even modern stadiums cannot match. We cannot replicate the Colosseum, not because we are less intelligent or capable, but because our world has changed. We have different values, different materials, and a different attitude toward time. However, looking at these arches, we learn an important lesson. True craftsmanship is timeless. What impressed you most about the Colosseum's construction? Was it the self-healing concrete, or perhaps the arena's flooding system for naval battles? Write your answer in the comments, and be sure to subscribe to the channel so you don't miss the next trips to the past.